Hello students, now we are going to see transportation problems. We are going to see how to find the optimal solution of a given transportation problem. For that we have only one method. It is called Modi method. And the expansion for Modi method is modified distribution method. It has another name, UV method. So using this method we are going to find the optimum solution. In my previous video, I have explained how to find the initial basic feasible solution using three methods: northwest corner rule, least cost or matrix minima method, or Vogel's approximation method. In short, we call that as VAM. If you want, you go through that video, and here for finding the optimal solution, we have only one method, which is Modi method. In my video itself, I have explained out of these three, Vogel's approximation method, VAM, will give the best initial basic feasible solution. So before we go into the optimal solution, first we have to find the initial basic feasible solution. For that, we are going to use VAM. So first we have to apply VAM, then we have to move on to Modi method. This is the problem given. They are asking you to solve the given transportation problem. Either they can give it like this, or they will ask you to find the optimum solution or optimal solution to the given TP. Anything, just solving the TP means it doesn't mean that we have to find the initial basic feasible solution. We have to find the optimum solution. So solving a TP means we have to find the optimum solution. So for that we have only one method, that is Modi method. This is the given TP, supplies are given, demands are given. We are going to find the optimum solution. First we have to confirm whether it is a balanced TP or not, balanced transportation or not. What do you mean by a balanced TP? A balanced TP, we can say the given TP is a balanced TP when summation AI is equal to summation Bj. So this is the condition for a balanced TP. Balanced TP means when summation AI is equal to summation Bj. What is summation AI and summation Bj? Supplies given are AI, that is the first value row total A1, and this is A2, A3. Summing this will give summation AI, A1 plus A2 plus A3. These column values, those values are B1, B2, B3 and B4. Summation Bj means B1 plus B2 plus B3 plus B4. If these two are equal means we can say the given TP is a balanced one. Here in this problem, summation A is 43 and summation Bj is also equal to 43. So both are equal, therefore it is a balanced one. So after confirming the given TP is a balanced one, we have to move on. If it is not unbalanced means later I will post a problem in an unbalanced TP. So for the given TP, we have to find the initial basic feasible solution. That method already I have explained in detail in my previous video. If you want to get more knowledge, you just go through that video. Here in short I have explained. So what is the first step? This VAM is having another name. It is called method of penalties. So first we have to calculate penalties for every row and column. What do you mean by a penalty? For example, if I consider this row, what do you mean by a penalty? Penalty means the difference between the minimum and the next minimum. Which is the minimum here? 13. And the next minimum is 16. So the difference between these two are 16 minus 13, the greater value minus smaller value. That is called as the difference. So which is 3. That is the penalty for the first row. Like that, we have to calculate the penalties for every row and column. That is step number 1. After calculating the penalties, we have to select the greatest penalty, maximum penalty. Here 10 is the maximum penalty and it corresponds to the fourth column. In that column, we have to locate the cost, least cost. So which is having the least cost out of these three? 13 is the least cost. In 13 only we are going to give the allocation. The allotment is going to made in this cell. So for this cell 11 and 15 we have to take the minimum of 11 comma 15. Which is the minimum? 11. So 11 only we are going to allot in this cell. If we allot 11 means this will become 0 and this will reduce to 4. So we have to delete this row when you go to the next step. Everything we can do in a single table. If you are well versed, you have a thorough knowledge in VAM means all together you can do in a single table. For beginners, we have to reduce one by one and we have to do it. Is it clear? And this is the next table I'm getting after deleting the first row. The same procedure for every row and every column we have to find the penalty. Penalties are nothing but the difference between the minimum and the next minimum. So I have given the penalties. Out of the penalties we have to select the maximum. 18 is the maximum, and in that cast we have to select the minimum. 23 is the minimum, and here 4, 13, 4 is the minimum. So 4 I have allotted. So this will become 0 and this will become 9. So deleting this column, we have to take the next table. In the table, same procedure, penalties we have to go, and the maximum penalty, minimum cast and the minimum allotment. So this will become 0 and this will reduce to 3. So deleting this column, we have to go with the next table. This is the next table. I have calculated the penalties. Out of the penalties, we have to select the minimum of it. We have 2 9s. Any 1 9 we can select. But usually, I will take the best one. Best one means I will take the minimum of it. Minimum means both are 9. You may ask which is the minimum. You can select any 9, either this or this, no problem. But when I take this 9, no, which is the minimum cast corresponds to this row. 18 is the minimum cast, and for that 12, 19. So 12 is the minimum. So 18 into 12 in this cell. Suppose if I take this 9, 18 is the minimum and the cast is 3. So which will give the minimum value? This will give the minimum value. So I have selected this 9. But it is not a rule. We can take any 1 9 and we can go with that. Okay. So if I take this 9, 18 is the minimum cast, and 3, 10, 3 is the minimum allotment I can make. So this will become 0 and this will become 7. So deleting this row, we have to take the next. Since we have only 2 cells, whatever balance we have now, we have to allot that. So 7 in this cell and 12 in this cell. The total is 19. So everything got exhausted. So we made all the allotments. After the allotments, all the allotments, we have to take everything in a single table. Whatever allotment we made now, we have to write in a single table. And we can check whether we allotted properly. See, this is 11, this is 11. Summing these 3, 6 plus 3, 9, 9 plus 4, 13, 13 we got. 7 plus 12 is 19. Column wise also 6, then 10, 12, 11 plus 4, 15. So when you check if the demand and supply have been splitted equally, that's correctly means whatever allotments you made, no, that is correct. After that, we have to write the initial basic feasible solution. How to write it? We have to multiply the allotment and cast. That is Cij into the allotment Xij. Cij means cast given the problem, these values. Xij means whatever allotments we may know here, those values. So 13 into 11, 17 into 6 plus 18 into 3 plus 23 into 4 plus 27 into 7 plus 18 into 12. So on the whole, we are getting the final answer as rupees 796. Next, moving into optimal solution. We are after this step only, we are going to find the optimum solution. Up to that, we got the initial basic feasible solution, that is called the starting solution. We may get the initial basic feasible solution as the optimal solution. We may get or a value which is lesser than this 796. Either we may get this answer alone or we may get an answer which is lesser than 796. Okay. Before going into the optimal solution, first we have to make sure the number of allotted cells, that is allocations, occupied cells, is equal to m plus n minus 1. Here m is the number of rows and n is the number of columns what is given in the problem. What is the number of rows here? Number of rows, that is m is equal to 3 and n is equal to number of columns, that is 4. Number of allotted cells you count 1, 2, 3, 4, 5, 6. So 3 plus 4 minus 1, which is 6. the number of allocations or allotted cells or occupied cells, whatever term we can use. No, we can use allocations, allotments, occupied cells are 6. Therefore, number of allocations is equal to m plus n minus 1. When this condition is getting satisfied means we are saying the given solution is a non-degenerate solution. If the number of solutions are less than m plus n minus 1 means the solution is degenerate, and the procedure for that is quite different. We have to start in a different way. That we are not going to do it. I can do it in a different video. Okay, so here I have taken the non-degenerate solution, that is the number of allocations is equal to m plus n minus 1. So after confirmation of this, we are moving to the next step. Next, we are going to write equations of the format Cij is equal to ui plus vj for all allotted cells, that is occupied cells. Occupied cells, we are going to write equations of the format Cij is equal to ui plus vj. So totally we have to get 6 equations. So this is the table what we got. We are going to write ui plus vj equal to Cij for all occupied cells. Occupied cells we can say, or allotted cells or allocations, whatever term you know, you can use it. Okay. So we are going to write equations of this format. Okay. For example, if I take the first allegation here, I would say you can write this as u1, u2, u3. Row wise you can write u, and column wise we can write V. So V1, V2, V3, V4. We are going to find the individual values using these equations. So I'm going to find what is U1, what is U2, what is U3, what is V1, what is V2, what is V3, and what is V4. Okay, let me write the equations first. For example, if I consider the first allocations U1 and this is V4. So the equation what I have now is U1 plus V4 equal to ui plus vj equal to Cij. What is the cast here? 13. So 13. Equation number 1 is u1 plus v4 equal to 13. The second one is u2 v1. So u2 plus v1 equal to 17. So the next third equation is, what is the third equation? u2 plus v2 equal to 18. Then u2 plus v4 equal to 23. Then u3 plus v2 equal to 27. Then u3 plus v3 equal to 18. So 1, 2, 3, 4, 5, 6. We got all the 6 equations. So we are going to find the individual values for u1, u2, u3, v1, v2, v3, v4 using these 6 set of equations. Okay. For that, first we have to fix any one term as 0. So usually I will take the first value as 0, that is u1 equal to 0. Then successfully we have to substitute whatever values we are getting. So one by one we have to substitute and we have to get the other 6 values. So let me substitute u1 as 0 in this equation, first equation. So u1 0 means 0 plus v4 equal to 13. So we are getting v4 as 13. So we are getting v4 as 13. So next, after getting these 2 values, we have to substitute the any one value. So in this equation we have v1 so v4, I'm sorry, I have taken wrongly. v4 is 13. I am sorry. So v4 is 13. Where we have v4 in this equation, we have v4. So we can substitute v4 value there. So u2 plus v4 value we got as 13 equal to 23. u2 is equal to 23 minus 13, that is 10. We may get negative answers also. All the values are not positive. We may get 0 or we may get positive or we may get negative values. So we took u1 0, we got v4, now we got u2. So after this u2, now I am moving on to the second equation. u2 value I got as 10, no. So 10 plus v1 equal to 17. v1 is equal to 17 minus 10, that is 7. So v1 equal to 7. After this v1, v4, u1, u2, we have to move on to the next one. u2 also, here also we have u2, so I can substitute that u2. So 10 plus v2 equal to 18. So v2 equal to 18 minus 10, that is 8. Next, here also we have u2, that already u2 plus v4, already we got v4, no, leave that. Now moving on to this, u3 plus v2, 8 equal to 27. So u3 equal to 27 minus 8, that is 19. So after that, moving on to the last one, v3, that is u3 is 19 plus v3 equal to 18. So v3 equal to 18 minus 19, which is minus 1. So it is minus 1. Is it clear how we are getting ui and vj values? After calculating all the individual values for ui and vj, we can check whether the answers what we got are correct or not. Okay, so see the first equation what we have, u1 plus v4. So u1 we got as 0, v4 is 13. 0 plus 13, 13. So this is correct. Okay, so next one is u2 v1, 10 plus 7, 17. u2 v2, so 10 plus 8, 18. Then u2 v4, 23. Then u3 v2, this is 27. Then u3 v3, 19 minus 1, it is 18. So whatever values we got, no, those values are correct. So next step is we are going to fill those values in the table. So I have written u1 equal to, no, so it is 0. The next one is 10 and the next one is 19. And here it is 7, 8, minus 1 and 13. So I have taken down all the values in the table. Next step is we are going to calculate one value. We are going to find a value dij which is equal to cij minus of ui plus vj for all unallotted unoccupied cells. That equation ui plus vj equal to cij we got, no, that is for all occupied cells. This equation we are going to find unoccupied cells. Okay, in some book they will use the term delta ij, and this may be reversed. ui plus vj minus cij. The procedure what we are using, no, that is dij is equal to cij minus of ui plus vj. And we have to make sure all the dij values are greater than 0. If it is greater than 0 means whatever answer we got, no, in using VAM, that is the final answer, that is the final solution, and the solution is unique. We have only one solution, that is unique. If any dij value is greater than 0 and at least one value equal to 0. Greater than 0 means only positive terms, right? If we have any one dij equal to 0 means that solution is also whatever we got in the previous step, that is the optimal solution, but it is not unique. We may get an alternative solution, but we are not going to find the alternative solution. We have to write it down in the final conclusion. Whatever answer we got in the previous step, that is the optimal solution we have to write down, and we have to insert the statement that it may have a alternative solution when we have this case. If all the values are positive means no problem, just you have to give the equation, that is a solution what we got in the previous step as the initial basic feasible solution we got, no, that is the final optimal solution and it is unique. If at least one is 0 means we have to write the statement, or else if we have any dij, at least one dij is less than 0, the procedure what we have to follow is different. That I will do in a different video, not in this video. In this problem, we are getting a solution. In this case, Dij is greater than 0. Negative means the procedure is different. I will do a different video later. So what are the unoccupied cells we have? This one. So here we have to calculate, I'm sorry, 1 minute. Here we have to calculate D11. This is D12, D13, then D23, D31 and D34. So all these things we have to calculate. For example, D11 means the cost what we have is 21. 21 minus of 0 plus 6. Like that we have to write all the equations. So these are the Dij values which we are going to calculate for all unoccupied cells. Occupied cells. This is a symbol for the term for all. For all unoccupied cells, we are going to find D11 is equal to, this is the cost C11 and the corresponding Vi plus Ui plus Vj. So 21 minus of 0 plus 7. So 21 minus 7 which is equal to 14 which is greater than 0. 16 minus 10 which is 6 which is also greater than 0. 25 minus 12, 13 greater than 0. 14, 10 plus of minus 1 means it is 14 minus of 10 minus 1 is 9. So 14 minus 9 which is 5 greater than 0. 32 minus 19 plus 27 is 26. So it is 6 greater than 0. And this is 41 minus of this is 32. 9 which is greater than 0. Therefore, all Dij values are greater than 0. Therefore, in our initial basic feasible solution, what we got? No, that is the final optimum solution. This solution we got no, that is the optimal solution. We are not able to find a better solution than this. So we have to write this as the optimal solution. So this is our final optimal solution. Whatever we got in the initial basic feasible solution, no, using VAM, that is the final thing we have written in this. We have to write in this way. Okay. So we started with Modi method and got all the values. And finally, when Dij values, all the Dij values are greater than 0. Dij means for all unoccupied cells, we have to find this one. So if all are greater than 0, we can say this is the solution and it is unique. If at least one Dij value is equal to 0 means the other terms are greater than 0 means we have to write the solution the same. But you have to mention the term. It also have an alternative solution. We are not going to find what it is. Okay. Just we have to mention this. It also have an alternative solution. If any one Dij value is less than 0 means the procedure is different. Now we are not discussing that. I will do a separate video having this problem. Is it clear how we did Modi method? Thank you.